Hello, in this lesson we will learn a little about the coordinate system in AutoCAD. After several years there has been a significant improvement in the entry of information into AutoCAD when it comes to setting points on the screen. But in some cases the old coordinate system is still used. Knowing the coordinate system, you will have more resources to create your drawings. I'm sorry, this may be the most boring class in the course, but it's worth it, I assure you. AutoCAD is initially configured with the Global Coordinate System, which is the software standard and represented in the graphical area by UCS icon. The coordinate system is nothing more than a system for locating points in space from a reference. Whereas we are going to work in a two-dimensional environment, the coordinate system is characterized by the Cartesian plane represented by the x and y axes. Where at the crossover of the axes, is the initial reference point. The x-axis represented horizontal, with positive values for the right and negative values for the left. And the y-axis represented vertically, with positive values up and negative down. In this sense the points on the screen will always be referenced by the initial x, y coordinate, which is the 0, 0 coordinate. So if we want to represent a distant point in the horizontal of 90 units and vertically of 20 units, the coordinate system for this point is 90, 20. Look at this other point. The coordinate of this point is -70 in x and -20 in y, i.e., coordinate -70, -20. To exemplify whether we want to make a circle exactly at this point, we activate the circle command. And instead of locating any point on the screen, we type 90, 20 and hit enter. Note that the center of the circumference was exactly at this coordinate. That is, we define the center of the circumference through a coordinate reference to the global coordinate system. Simply by typing the x value at comma and the value in y. We set the radius to 5 and enter to end this circumference. We are not actually going to use this much in practice, but it's important to know the fundamental concept in AutoCAD. Now we have some drawings on the screen. See that it would be impractical to use the global coordinate system to make these simple drawings, but this was the beginning of AutoCAD in the 1980s. Now it's a lot easier, and let's see how much easier it gets. The Cartesian coordinate system can also be called rectangular coordinates, represented by the x, y coordinates. AutoCAD also has the polar coordinate system, represented by a distance and an angle. In this scheme we visualize some lines and the angles relative to the horizontal. As an example, note the angle of 60 degrees, 135 degrees and the 270-degree angle. That is, the global polar coordinates always have as reference the positive angle counted from a horizontal, 0 angle. And growing counterclockwise. After several decades now we have easier ways to enter with precise drawing measurements and coordinates. One of the factors that facilitated was the dynamic input function, so we can make this drawing easily. As an example, we will activate the line command and click anywhere on the screen. With the function orthogonal and cursor positioning, we enter the dimensions of the lines until the drawing ends. In this other design, we use the polar coordinate system, but not the global one, but the location, which always uses as a reference to the last defined point. In this case with a maximum of 180 degrees up or down, as we have seen in previous classes. We can then easily make this drawing using the facilities of AutoCAD, typing the distance, typing tab and typing the angle relative to the horizontal. Depending on the command we are using, AutoCAD requests a coordinate input or other information. Often if you enter only one value, in cases where you can also enter with a coordinate. AutoCAD interprets that you are entering with a distance from the last point in the direction your cursor is. In this way we were able to make this first drawing with the active orthogonal function. In this other case, we use the local polar coordinate. With dynamic input turned off, things work a little different. We will also disable the orthogonal function and make this drawing. We activate the line command and set any point on the screen. If we type 20 tab 45 it won't work, because without dynamic input the polar coordinate needs to use the less than signal. i.e., you need to type the distance 20 symbol less than to activate the polar coordinate and 45 to set the angle. Let's type in and see if it works. Note that not, because AutoCAD has located this point 20 units at 45 degrees from its point of origin 0, 0. So we need to use another symbol to define that we want to use the last reference point, and this symbol is the @ Let's start again the line, set any point and now let's type correct, at 20 less than 45 enter, note that the line was done successfully. Let's continue, at 20 less than 135 enter, at 20 less than 225 enter. Note that now the angles are always in relation to horizontal and always counterclockwise until full 360. And to finish we click on Close. We use here the local polar coordinate system or relative polar coordinate, relative to the last point. And also works for the rectangular coordinate system, which we can call local or relative rectangular coordinates. As an example we will make this drawing. We activate the line command, define any point and type at 60, 0 enter, which means an offset of 60 units horizontally and 0 vertically. Now we type at 0, 40 enter, at 60, 0 enter and close to close the geometry. The important thing here is to know that we can use it to reference the last defined coordinate. That we can use either the rectangular coordinate system x, y or the polar coordinate system distance and angle. And also that we have many facilities to set points in AutoCAD. To facilitate manipulation in AutoCAD always leave dynamic input active. We're just at the beginning, let's see many facilities from now on, with new commands and make lots of drawings for you to become an expert on the subject. Until next class.